when it comes to my experience and my area of expertise, which includes dust hazard analysis, electrostatic hazard analysis, also have area classification, process hazard analysis, which include LOPA, HAZOP, What-If, HAZOP. I also get involved in PSM audit, also train as a trainer. So with this webinar, the main objective will cover the various methodology of process hazard analysis. And also we'll be discussing the various application of various methodologies, which include the HAZOP, HAZOP, and also we dive into some of the pros and cons of these methodologies. So for Sigma-HSE, we are almost everywhere in the world. So our presence include the North and South American location, which is our main office located in New Hampshire in the United States. And also in the Europe, our office is located in Winchester in the UK. And we have the Asia, we have our office located in New Delhi in India. We also have 2 ISO accredited laboratories, and one in UK and another one in India. And we are hoping to get another one soon in the United States, where we will be serving the North and South America. So when it comes to our area of expertise, we have our consulting group. We dive into various process safety expertise, such as area classification, DHAs, PHAs, reactive chemicals, hazard, and so on. And also the testing, as I did mention, we have 2 labs, one in UK, one in India, and also have a various training platforms where we train various industries on how we can prevent hazard associated with their operation. With the testing, we do gas explosion testing, we have gas vapor fire and explosion testing. Also, we have reactive chemical testing too. And both labs in UK and India all have the capabilities to perform such testing. So first of all, let's start with the process hazard analysis. And I'm going to summarize it in just using a typical example. Consider that you have a refinery, or you are at the stage of conceptual phase or design phase to actually establish your plan. So the process analysis or process hazard analysis comprises of a team of people reviewing each of the operation, try to identify each of the hazard associated with these operations, whether the material, whether the various equipment or the process or the flow. So based on the identification of the hazard, they are able to provide various mitigative approach to prevent this hazard. So there are several methodologies that could be used. That is what I'll be discussing more in this presentation. So it starts with number 1, collection of your data, maybe walk through the facility to look at the various operation. Then you start the hazard assessment. You try to categorize the risks associated with the operation, and also implementation and mitigation of any findings. So which could be at the initial conceptual phase, or maybe in the middle of the operation, or during the modification of any operation. So with this process hazard analysis, you are able to identify this hazard before maybe they becomes an event to cause any catastrophic event. So that is the basic fundamental of this process hazard analysis. But there are several tools which have been used in assessing this kind of hazard. So these tools, number 1 here is the hazard. And also we have the checklist, we have the what-if, we have the HAZOP, which is very, very common. And also after maybe the HAZOP, there's also a follow-up, which is methodology such as the LOPA. So I'll be diving into each of these methodologies, highlighting on the pros and the cons of each of these methodologies. So the first one is hazard. HAZOP is hazard identification studies. which is a systematic and comprehensive process which is used in process safety consulting to identify and analyze potential hazard associated with particular facility, operation, or project. And the primary goal is always to identify and address this potential risk in early stage or in the design or conceptual phase of an operation. And with this hazard, a group of team or meet and brainstorm whether the equipment you are the process of maybe designing a new operation or design a new process. At the conceptual or at the design phase, the group of people meet to discuss all the possible hazards that could actually happen or that should actually be considered in the initial stage. And now we can find a way to mitigate this hazard at the conceptual phase. Because knowing the hazard at the design phase is very, very important, because after the operations or after the process is running, you try to add more safety measures. That means you need to tear down some of these operations. You need to now disassemble some of this equipment to add on the safety measures, and that is very cost effective. So knowing all these hazards at the conceptual phase is very, very important. So normal hazard is usually used to do such kind of assessment. So what are the pros of hazard? So the first one is what early risk recognition. So we are able to identify the risk at the design phase or at the concept phase when it comes to the hazard. So in this case, the group of people will be able to scrutinize each of the operations at the design phase. And in this case, they'll be able to determine or detect any potential hazard that could actually occur during the design phase. And also it is a multidisciplinary approach. So it's not one-man show. It's always a team of people from different diverse backgrounds, such as chemical engineers, mechanical engineers, electrical engineers, safety engineers. All these people meet and discuss the various hazards associated with the operation. So it's able to give diverse opinions, not one man reviewing the whole process where the person can miss one or two hazards. And also very comprehensive. Because at the initial stage, they are able to actually dive into the detail of the operation, which start with maybe the material that they are going to handle, the process, the various equipment. So it gives a very comprehensive and broad range or cover various broad range of this operation, and is able to help identify this hazard at the initial stage and also improve decision making. So if you know the hazard at the conceptual phase, you'll be able to mitigate this hazard, and this hazard help to improve this decision making, whether to move on with the operation or to stop the operation, whether maybe where you are citing the various equipment is appropriate or not, whether maybe the equipment that you're going to purchase is appropriate or not. Because knowing this hazard will actually help you to know what kind of decision that the team needs to take moving forward before installing this operation. Cost saving, as I mentioned initially, since you know the hazard at the initial stage, it actually helps you to actually save cost, because you don't need to wait at the latter part of the operation in order to bring things down to install the safety measures. However, knowing all the safety measures at the initial stage, you are already adding on or actually implementing all the safety measures at the initial phase. So it saves cost and it's low time commitment. It's not that tall compared to HAZOP, where it can take weeks or sometimes months to actually review. It depends on the complexity of the operation, and can be completed prior to PI and ID development. So this can actually happen prior to designing your equipment. You can actually, it can give you just the general overview of the hazard. But what are some of the disadvantages of this hazard? The first one is subjectivity, because we have different kind of people who will be actually involved in assessing this hazard. Since different kind of people, they have different opinions. So it's always difficult to actually come into conclusion with a specific risk or maybe the consequence that would, or the likelihood of an event actually occurring, because different kind of people with different opinions. So it makes it difficult to make just a straight decision. Limited predictive accuracy. That is very, very important, because this is under at the conceptual phase of the operation. So there, we don't have any quantitative data. We don't have any data to support most of the decisions that will be made. So it makes everything actually limited in this assessment and focus on only the design. So it's only the design phase. So you cannot actually do HAZOP when the equipments are already, or the process is now in operational. You can only use this one in only. So these are some of the limitations. And resource intensive, yes, because since maybe there will be a group of people actually who will be conveyed at a specific area to brainstorm, you need this resource. You need to pull maybe the engineers from their normal schedule. You need to maybe have some outside consultants. So it's actually resource intensive, and also limited in identifying scenarios. Since at the conceptual phase is always going to be difficult to actually identify unforeseen events, because some of these hazards are apparent during the operational phase. So because this is conceptual phase, it's always going to be difficult to identify some of the hazard that will actually occur at the latter stage of this operation. And also easy to miss potential hazard if group lack key knowledge base. So that is very, very important, because if the group does not have the foresight of the operation, because since it's not even operational, we don't know the flow rate, we don't know much of these operations. So if the group does not have actual insight into the operation, it will be very difficult for them to identify all the hazards associated with this operation. So roughly, this is the hazard, as I mentioned, conceptual phase, and it's able to detect most of the hazard at the initial phase, but it also is all limitations, since there's no data available, and limitation of the process itself is able to, we are not able to identify all the hazard. The next methodology here is the process safety checklist analysis involve the use of checklists to systematically assess and ensure the implementation of key elements of process safety within an organization. And checklist is a tool to evaluate whether organization is effectively implementing the essential component of a robust safety management system. So the checklist system is like you have a standard systematic approach or lay down questions. We have our process management system already in operation. So with the checklist, we have the questionnaires, we have the tick the box. This is what is termed as the tick the box. So with the tick the box, we come to your facility, we know what your expectation is, we know what the standards are. Then we come to compare what you have with the standards to ensure whether you are in compliance with what is supposed to be done. So that is the checklist approach. And there's always various limitations and various advantages of this checklist approach. So what are some of the advantages? So it's systematic evaluation. Since you have the standard questions, you have the standard sheet, you have the standard checklist. For example, in case I am checking a pump, I'll be able to check, okay, what is the flow rate of the pump? What is this? What is this? Because you have the checklist that you're going to actually use to compare with the system. So it makes everything systematic evaluation. And whatever is in the book, you don't miss it. And also a standardization, because you have the actual standard that you are going to use. For example, in case have the various questionnaires that you're going to use compared to what the operations are doing. So for instance, in case I go and check an operation and dust collector, so first of all, I'll check, okay, a dust collector is supposed to have explosion relief vent. A dust collector is supposed to have explosion isolation. Maybe it's supposed to be bonded and grounded the inside filters. So I have this predetermined questionnaires, checklist that I'm going to use to ensure that you are in compliance with it. So if I come and I notice that, okay, you are handling maybe titanium, or you are handling maybe aluminum dust, you're using a dry type dust collector, and with this dust collector, you don't have isolation, you don't have explosion, maybe relief vent, or maybe it's not a west clapper, automatically I'll fail you based on the checklist, because that is the standard I'm supposed to follow. And the checklist is also easy to follow because I have my questions that I'm going to use to actually assess the standardization of your operation. And there's good documentation because I have the questions I'm going to use, so I'll be able to document everything. Because if maybe I ask you, do you have A, and you don't have, I'll indicate why you don't have A, I'll give these reasons there. So I'm able to document each scenarios associated with this operation. And also identification of deficiencies, because since I have my standard questions or my standard checklist that I'm going to use, I'll be able to easily identify deficiencies. As I gave example in the dust collector scenario, if I come and you don't have explosion isolation, I will easily see because I have my checklist that I'm going to use to mark to see whether you have it or not. It also serves as a training tool because since actually I have the specific guidelines that I'm following, we can easily be used as a training tool for the facility. Because in this case, I come to your site, I know what you're supposed to do, and I come with the various standards which you are supposed to meet. And in case you are not able to meet, I'll give you maybe your results, and it can serve as a training tool that the facility can use to improve their operation. With a checklist, it's a low time commitment because it's not like a total brainstorming. We don't need a lot of people or the time that is going to be used. It's not like HAZOP, because this one I have my fundamental questions that we are going to use to follow to actually assess your operation. There's also disadvantage, subjectivity. Normally, it's also a team approach. And team approach, everybody has their own opinion, how they want to categorize the various risks. Sometimes you can say this is right, somebody might say this is wrong. So it gives various diverse opinion, which makes sometimes categorizing of the risks, maybe the likelihood of the maybe a specific event or the consequence of a specific event is going to make things difficult. Limited depth. So that is also limited because now I have the questions I'm going to, so I don't think outside the box because I have a specific guidelines that I need to actually follow when it comes to the checklist approach. And it will also become over reliance because since we have the standardized questions that I'm supposed to follow, in this case, I over rely on it and I close my mind for only for additional thought or maybe to think outside the box because that is what I have been sent to do, or that is what the team has been sent to do to follow a specific guideline. So they over rely on this operation or the checklist that has been provided without actually thinking what could actually happen in the absence of this checklist. And also inflexibility because it's static system. You are not flexible to also broaden your scope to oversee or see other events that could actually happen in the operation. So this makes the checklist more complicated. Personally, it's not my favorite because I want to explore. I want to do something outside the box. I want to think ahead. I don't want to be stuck with maybe point A, maybe do you have this, do you have this, do you have this? I want to review the operation to see beyond what is actually listed on the checklist sheet. And it's not comprehensive enough. That's why I just mentioned it's not comprehensive, because it's limited to the actual question that has actually been given to us to actually follow the standard. And it does not allow for identification of new hazard. And I've already mentioned, because as I'm going, or as the team mates, they're only focusing on the hazard that has been identified on the list that they're supposed to follow. So it kind of make a kind of a closed box. It does not allow them to think outside the box. So what is the next one is what if? What if, or process safety what if, involve a structured decision among multidisciplinary team to explore hypothetical situation and assess their potential consequence. And the goal is to proactively identify and understand potential risks in order to develop effective risk management. And normally this is also a team effort, and I have been involved in several what if analysis. What if is, for example, in case I come to your facility, I have a reactor. And so one question that could occur here is, what if the reactor fails? So that is a hypothetical question. What if the reactor fails? What if there's overheating of the reactor? What if there's no flow? What if? So everything is just a hypothetical question that we raise to. So based on the question that we raise, we are able to find, okay, what if this happened? Then we have to now sit down as a team. Okay, this will happen if this actually occur. Explosion will happen in a dust collector if maybe the amount of dust concentration is above the explosive concentration, or if there is a potential ignition source. So this is the what if methodology. So where we use hypothetically questions to actually try to find the consequence of a specific event, and we try to find a way to mitigate this kind of consequence or this kind of event. And personally, it's sometimes effective. It's very, very effective if the team actually know what they are doing. If the team are experienced enough, they are able to actually foresee some of these hazards, because we actually assume all the scenarios, all the event that could actually happens in this operation. What is the some of the advantages and disadvantages of the what if assessment? So the advantage number one, early hazard identification. So based on the brainstorming of the operation, some of these early hazard could easily be identified, because we have used these hypothetical questions to try to simulate what could actually happen in this operation. So what if maybe the explosion happens? So the event that could happen here is what? An explosion. What if maybe there's a fire risk? What if there's a leak? So we try to pre-identify all these hazards in the early stage and try to find a way to mitigate it. And the next advantage is multidisciplinary approach. So this is not done by one person. It's not one man show. It's also another team of people sitting down, trying to discuss all the events that could actually go wrong, and try to find a way to resolve that event. Try to find a way, and always we try to also categorize the risks, which is actually qualitative wise, not quantitative. We don't have data to actually assess to give accurate risk. However, based on the qualitative information that we have, we'll be able to still assess the risk. Flexibility and adaptability. So this one is not like a checklist where we have a specific questions to follow. This one, we are flexible to raise any concern. We are flexible to actually pose any question to actually find all the hazard associated with a specific operation. And also it promotes team communication. That is very, very important, because we raise a question. What if this happened? Then I will say, okay, this will actually happen if this occurs. Another person also bring an opinion. This will happen if this. So it promotes team communication where everybody has the views that they have, their experience to share, and this makes us take effective decision. Qualitative insights, I mentioned it as this is not quantitative, so it's easy to use. Quantitative, you need to dig for more data, you need to know the failure rate of equipment and so on. But with the what if is qualitative, so you don't need to actually think of how to get all those. Some of these data are trivial. Some of these maybe the pump, what is the failure rate of the pump, what is the failure rate maybe for maybe a heater. We don't need all those things. Everything is qualitative. And also we have documentation. Everything is well documented because it's a team approach, and every solution that we brings out, we actually document it. And sometimes complement to quantitative method. So before we do HAZOP is also semi-quantitative, but it's not full quantitative, but it's also kind of complement. You can use this as the fundamental for quantitative assessment. Require less effort than HAZOP. Yes, HAZOP is more intensive and allow for identification of unique hazard that wouldn't be identified during a simpler process or a checklist. So this gives more in-depth, more than the checklist. So preferably, if I'm assessing, I'll prefer to go with the what if rather than a checklist. What about the cons? The disadvantage, subjectivity, which is something that so far as there's a team or a group of people who are working on achieving a specific goal, automatically there will be people's diverse opinion, which makes it difficult to make a specific decision. Lack of quantitative data. This is purely qualitative. So you don't have any data to support any of the risk decisions that we take. So we don't know the failure rate of any of the equipment to know what percentage can this material or this equipment fail. We don't know any data to support any of our claims. So it's kind of less quantitative, and some of the risks that we choose are not 100% reliable. A team approach, so resource intensive and limited to identify scenarios. Yeah, so in this case, we just give hypothetically scenarios or questions. And in this case, we does not review each point of the operation like HAZOP does. So in this scenario, we don't actually identify all the scenarios. Sometimes we might miss some of the questions because in case we are not able to phrase or propose the right what if question, that means we miss the point. We might miss that particular hazard. So it has its own limitation, may not capture the rare event. Yeah. So if we miss a specific question, that means that actual event will also be missed, and that will actually happens in the operation. Difficult in risk ranking. So in this case, it's qualitative. We don't have the data to support. So it's difficult for us to say, okay, we need to give 3 or 4 or 5. Everything is just qualitative. We assume the ranking of the various rates and require knowledge and skills of team to make the most of the technique or so this assessment, we only rely on the team effort. We don't have any data to support it. So it kind of, these are some of the disadvantages of the what if. It's only team decision. There's no data to support whatever that we say. We can miss most of the information because it depends on the questions that we pose, the questions that we ask. So the next one, which is most commonly used in the HAZOP, and which is the Hazard and Operability Studies. So HAZOP is a systematic and structured hazard analysis technique used in process safety to identify potential hazard and operation issues in facility system and operation. Now, the primary objective of HAZOP is to examine each component operation of a system to identify deviation from the intent design and assess potential consequences. So for HAZOP, we identify individual components or we call it node. And we have deviations and guide wires. So we are being guided. So for example, for HAZOP, if I have my tank, or maybe a tank or a silo or maybe a bin. So one thing that we could say here is, what about if there's overflow? Or what about if maybe the tank is empty? Or what about if the system overheat? So what we do with the HAZOP here is we are being guided with specific keywords. So it's not like the what if that you can just frame or propose or any kind of hypothetical question. This one is you select a specific node, you select a specific equipment, then you use the deviations. So you have the guide words, which could be the process condition, and I'll go into the guide words very soon. So in this case, you actually decide what you want to do. You select each of the node, each section of the operation. Then you assess that operation based on a specific guide words. And these are the guide words. So HAZOP use a standardized list of guide words as a modifier to process parameter to hypothesis deviation from the desired event. So the deviation is what the guide word plus the parameter, and actually the team actually analyze the deviation to determine if a hazardous condition will occur or if an important operation upset will actually be discovered. That is what the HAZOP. The team's understanding of the desired intent is key to development of their significant deviations. For example, if maybe I have a specific situation, hazardous condition, maybe overheating of a system, or maybe the equipment, or maybe I have my reactor and we don't get the feed into the reactor. So what could be the scenario? We could use any of these keywords, no or none, say the complete negation of what the intent. So in this case, we want A to go to B, and A didn't get to B. So that means we use the deviation, the notation as of no or none. That means it couldn't get to the actual intent. We have more. More is what? A quantitative increase of the desired intent. So in case I want to get to A, then it increase. Maybe at the I want to get from A to B. So I'm expecting B at my destination. Then when I get to B, I see C there. So that means there has been something addition to the B that I'm expecting. So there's quantitative increase of increase over the desired event. So that is what more. If I have more overflow, maybe the temperature actually increases, enough pressure in the system. So this is something which is more than what I expect. We also have less. Less is maybe I expect the level to get to point B, but when I go to B, I have B minus. That means I couldn't get to the level that I'm looking at. So these are the guidelines. So as well as in case there's some additional activity that happens, part of maybe there's something that incomplete combustion or incomplete reaction happening in the system. A reverse is when I want to maybe have a specific reaction, then there was no, I couldn't get the intent. There's logical opposite of what I'm doing. I remember working in a mining company where they installed the pump in the wrong direction. So that means that is a reverse. Instead of the feed going to maybe point A, it's reversing because they changed the direction of the pump, and which caused a massive event. So that is some of the keywords that we select. And other than is a complete substitution. No part of the intent occur. So these are the guide words which are actually used for HAZOP, and it's very comprehensive, and it's being guided by these the guide words and this deviation with these parameters. And the person leading needs to actually understand these deviations and these guide words. So even though HAZOP is the most common use, it has its own advantage and disadvantages. So for some of the advantage include comprehensive analysis. So it's very detailed. HAZOP is very detailed. So it kind of actually assess or analyze each of the operation or each of the situation to understand what could actually go on, and based on the guide wires and the deviation that we are able to actually assess the hazard or the risks associated with it. Early determination of risk, yeah, we can also do it at the conceptual phase or the design phase, and it will help us to identify the risks at the initial stage. Multidisciplinary, yes, it's not one. It's been done by a team of individuals who are experienced. It could be chemical engineers, mechanical engineers, it could be safety engineers. So we could all meet. And normally, I go in as a subject expert where I'll be guiding with my experience, because being visited over 200 to 300 facilities across the globe, wherever that you are facing, maybe I might have seen it somewhere. So I come in with my experience to guide the team on the best decision to take. And this is structured methodology because we have a specific guidelines and deviation, the keywords that we are following, and we go through the operation from point A, B, so equipment A, the node A, B, C, just follow everything systematically. Everything that we do is well communicated because there's teamwork and everybody has a way to express the opinion based on their experience level. Also have good documentation, a comprehensive review of the operation also, and in addition to identifying the safety net, allow for a review of operational concern. So the HAZOP give, among all of them, HAZOP give more comprehensive compared to the other tools that are being used to assess hazard in our process. The disadvantage include resource intensive. It takes time. If you have a complex operation, sometimes it could take more than a week to review everything, which makes resource very, very intensive because you need a team of people sitting down, reviewing each of the operation. And also subjectivity, we have team of people. Everybody has their own opinion. People might be thinking, everybody have their own way of thinking. Maybe somebody could say maybe the risk of this happening is low, somebody would say it's high. So at least if the team leader is experienced, then he can actually guide. Otherwise, sometimes it could be a long talk. So because everybody has their different opinion, and it only focuses on deviations. Unlike maybe what if, where maybe you can raise any question that you guys can actually analyze the hypothetical question to find solution to it. This is, we have a specific guideline, deviation, focus on what could go wrong. May not consider system dynamics, because since we have a specific keywords and deviation, maybe we don't consider the system dynamic, what could go wrong, what could go, the dynamics of the system, the changing of the system. So it does not consider it. Limited quantitative analysis, we still don't have data to assess it. It's not like quantitative risk assessment or maybe LOPA. That is why after HAZOP, the specific high risk event or specific high risk situation, we move ahead to do a follow-up with the LOPA. With the LOPA, we are able to use quantitative data to actually mitigate the various risks. And also requires skills facilitator, and I did mention it. If you have an inexperienced facilitator, people are going to overwhelm him, and which is going to be very, very bad. And I've been in one of them where the facilitator, I don't know whether he was a little bit shaky or something like that. So people were over talking and he couldn't control the team, and which can make things very ugly and very, the decision making will not be accurate and may generate a large number of recommendations. So which is also the situation, because discussion, looking at the various scenarios, you can end up raising over 100 recommendations. And implementing these are going to be very, very difficult and super time consuming, because it could take a week or sometimes 2 weeks for a complex operation. So after the HAZOP, the rare undesired event, so we can select one specific system that we know the risk associated with this unit is really high, and we can do a follow-up called a LOPA. So we have the LOPA, layer of protection assessment, which is what is a risk management technique used in the process industry to assess and control risk associated with hazardous process. The aim is to ensure that multiple independent layers of protection are in place to actually reduce the risk of hazardous event to acceptable level. And the key aspect of LOPA is the ability to provide a clear and a structured approach for decision making regarding safety investment. So as I mentioned, after the HAZOP, we noticed that, okay, the risk of overheating of a dryer is super high. So then we will take that particular event, then we will jump to the next stage, which is the LOPA. Then we will come, okay, the risk of overheating of a dryer is high. What is the level of safety? What are the level of measures that maybe is 6? How can we reduce it to 2 or 1 to acceptable level? So what do we need to do? The first thing here is, okay, first of all, can we reduce the operation temperature? Somebody will say yes, somebody will also say no. If it's yes, okay, we have the quantitative data. What is the failure rate of maybe the safety sensors or maybe the overheating system? So based on the data we have, then we can categorize and say, okay, doing point A is going to reduce it to 4. So that means you have cleared the first layer. Then after that, okay, now it's still 4, it's still not acceptable. How do we move it to 3? Then we come, okay, what about if we have maybe an alarm or cooling system? I'm just using hypothetically scenario. Cooling system, in case maybe it's overheat, we have cooling system, maybe heat exchanger, something which is going to cool it. Okay, maybe that one, the probability of that happening this, then let's move it to maybe 3. Maybe 3 is still not acceptable. Then what is the next step? The next step that we could consider here is, okay, let's have an alarm system, an interlock system with a system so that in case maybe there's overheating to shut down the whole process. Okay, what is the risk associated with it? What is the failure rate of the alarm system? We consider everything, then we move with it 2. 2 is acceptable, that's the borderline. Okay, what do we need to do in case nothing happens? All these measures is we still have overheating. Maybe let's have a fire suppression system in the system so that in case there's overheating, to just quench everything, there's a fire inside. So then it reduces it to 1. So that is the LOPA, where we know the event. We kind of categorize each of the levels where we can control, or layers where we can reduce the rate from unacceptable to acceptable level. So that is the LOPA. The LOPA also have its own advantages and disadvantages. Some of the pros are simplified risk assessment. So in this case, you don't start from scratch. There have been already what-if, maybe a HAZOP, which has already been completed. And since it has already been completed, you base on the event with high risk and now move on to do the risk assessment and only focus on critical scenarios. LOPA does not consider scenario which maybe the possibility of occurrence is maybe negligible or maybe it's not critical enough. It always focuses on super critical scenarios that in case something happened, it could actually affect the entire plant or maybe the neighborhood, the environment, maybe accidental release of maybe, and I think we all know LOPA, the BOPA incident, where there was the release of hazardous material which actually kills thousands of people, and people are still having the effect. So these are the critical scenarios that are being considered. And also is quantitative. So we use data, everything is based on data. This we don't guess. So that's why it's able to give the exact risks associated with the operation and facilitate decision making. So in this case, after putting the various layers, we are able to determine whether maybe the decision that you are going to take to build the plant at a specific location is actually needed or not. And the advantage also include subjectivity in parameters. You know, some of these data is difficult to get, number one. Some of these data are also hypothetical. Some of these data, number one, source are sometimes questionable. So we only use random failure mode of the failure mode of the various equipment of the various system. So it's difficult to maybe make a specific decision on the parameters that we are actually focusing. Limited detail. Yes, we are focusing on one specific scenario. An assumption of independence and limited of complex systems. So as I mentioned, it only focused on a specific event and how we can put layers to mitigate or to reduce the risk associated with the specific hazardous scenario. So I think that brings us to the end. And please, in case you have any question, you can type it and we'll see it, and or you can raise your hand and we'll be able to answer any questions that you have. And in case you have any questions, and you can call us. Our phone number is there, and you can send us an email. We'll be more than happy to assist you. We have people across the globe, so wherever that you find yourself, we can reach you. If you're in Europe, our UK team, and they can also come to US and also support us. We can go there and support them. We have our Asian team. So just reach out to us, and we'll be more than happy to actually assist your operations and ensure that your operation is safe. Going on, these are some of the services that we actually offer. And we do the consulting preliminary hazard assessment. We have the DHA team. We have the dust management system, where maybe you have your facility that you want us to actually come there and do some initial assessment. We do investigation. We have testing. We have training. So I can see there's let me see which is the best practice. Okay, so I have a question here. They say, which is the best practice worldwide? So each one of them, each one of them could be used depending on the individual scenarios that you want to you have. For example, at the conceptual phase, you have to do the hazard because you don't have any data to support it. And if the operations, for complex operations, you can use the HAZOP. For super less complex operation, you can use the What-If. And after the HAZOP, you can also move on with the LOPA. So there's no a specific best practice. It all depends on the scenario that you find yourself. So that is why it's always advisable, based on your scenario, you talk to a consultant, somebody who actually have been to these kind of operations or have done several of these. They can actually guide you which one is best for your operation. So we don't have any best practice or best, which one is the best to use. Each scenario is different. I hope I answer your question. Yeah, so I'm still open for any question that you might have. And you can also send us email with the questions. And going forward, we also have a training for combustible dust. We have dust management course. We also do the process hazard, and that will be a full course which will go in details. We'll have various case studies And so we also have another question here. Let me just move in. You said LOPA plus HAZOP plus LOPA are the best ones. So yes, that it depends. So LOPA only consider the high risk scenario after completing whether what if or maybe any scenario that you think is super high hazardous or high scenario, then we do the LOPA as a follow-up. LOPA and the bow tie, there's other tools too. We have the bow tie, LOPA, and these are all follow-up. Yes, HAZOP is a really good tool because it's very, very comprehensive. So if you say LOPA, HAZOP plus LOPA are the best ones, I would say yes, because HAZOP is the best among the three, the what if, the HAZOP, and also the checklist. HAZOP is more comprehensive, and after HAZOP, then you choose a specific scenario and you now do the LOPA. So I would say yes, but it all depends on the specific scenario that you find yourself. I hope I answer your question. So we still have 5 minutes to go, so I'm still waiting in case you have any question. I'll be more than happy, and you can also contact us direct. And there's another question here. Let me see here. Okay, say thank you. Okay, thank you very much. Thank you very much. Yeah, we still have 4 minutes, so we are open for any discussion. And moving forward to what we also, and we have our team are always available to actually communicate. We have complimentary free discussion. So in case you have any scenario we want us to discuss to see how best we can help you, you can always reach out to our team. Our laboratory people are really professional. They are all certified to do the various tests, and our engineers are also well trained. So you can reach out to us, and we'll be more than happy to always communicate, schedule maybe one-to-one meeting with the team, with your team, to actually see how best we could help you. Any question? So we have 3 minutes to go. So if there's any question, then thank you everybody for actually joining this webinar today. And we'll be sending a follow-up email. So do your best to respond to the email with all the questions, additional questions you might have, or the issues that you might have with your operation. And we'll be more than happy to okay, said, do you have online course? No, at this point, we don't have any online course, no. But we can do one-on-one course with the individual. So in case you want to actually get trained on a specific, yes, we also do both HAZOP and LOPA workshop. In case you want, we can actually design a workshop for you and your team, where we will dive more into this assessment. So we can do, maybe can we be 3 days workshop with, in case you want to learn much about the HAZOP and the LOPA, how it's being done. We will use various scenarios, various work case scenarios to actually train you to actually understand how they are being performed. So I can see that the questions are still coming. So yeah, feel free to reach out to us always. So I'll be more than happy to actually answer all your questions. And thank you once again, everybody. So in case they send the email, please do best to respond to our email with all the questions you might have and every situation that you have in your facility. And we will proactively jump in and support your team. Thank you very much. And we end this webinar today. Thanks.